The main goal of this solution was to test how Uniswap v4 can be used as a way to enable unstoppable transfers without directly revealing the sender's address. The concept of the solution is illustrated in the sequence diagram. We assume that Alice already has a liquidity position in Uniswap v4 for her favorite stablecoin pairs, for example USDT and USDC, and she wants to send to USDT to Bob. To do this, she needs to perform the following steps. First, she delegates her address to a smart wallet using a Uniswap Calibre account abstraction flow. Next, the required amount of liquidity is withdrawn from her Uniswap position and a newly created temporary wallet. Then the USDT portion is swapped into USDT. Finally, 2 USDT are transferred to Bob. Step 2, 3, and 4 are executed within a single transaction. At the time of recording this video, we use a custom script to perform this flow, and this script is included in the project repository as well. A key component of this solution is the proxy smart wallet contract. Liquidity is withdrawn from Alice's Uniswap position directly into this contract because in our rate model we assume that Alice E or A may already be blocked at that point. The USDC to USDT swap is executed by the proxy wallet itself, and after swap a full amount, in this example to USDT, is transferred to Bob. In the current version we made several simplifying assumptions to validate the concept. For example, slippage control is not yet enforced. The contract deployed on chain is used as an implementation. A second contract, a factory, creates ephemeral proxy wallet using EIP1167, the minimal proxy standard for low-cost contract cloning. As a result, the observed sender on chain is a proxy wallet, not Alice E or A, while the liquidity position can continue earning Uniswap LP's fee while idle. Now we can demo the solution end-to-end. As I said before, we use a custom script to perform this flow. After cloning the wrapper, we run the full test suite for the contracts we just described, and everything passes well. We also verify that Alice has executed the EIP7702 delegation transaction from her address, so she can use Uniswap Calibre while still operating in the context of the E or A. As I mentioned before, we assume that Alice already holds a position in Uniswap v4, and here we can confirm in the Uniswap app UI. Let's launch the script with the pre-configured parameters. We are using Foundry's key store, so we need to enter the password. In the script, we sign the prepared call data with Alice's private key. After that, we ask Bob to broadcast the signed transaction to the network. This demonstrates the flexibility of use cases enabled by account abstraction. Great, now let's take a closer look at the transaction in the Block Explorer and break it down in detail. So here we go. Here we can see that the transaction is initiated by Bob's address. Since Alice's address has been temporarily transformed into a smart contract, we confirm that Bob is interacting directly with it. Next, we observe that a smart contract was created within the transactions. This is precisely the minimal proxy for the temporary wallet. We can see a portion of Alice's position being withdrawn to this new wallet, 2 tokens. Following that, a swap occurs. USDC is exchanged for USDT. Finally, the USDT is transferred to Bob. The event tab provides a detailed step-by-step log of all these actions. In the project repository's README, we have listed the addresses of the deployed smart contracts. These are live in the BSC and Unichain network. A link to the detailed transaction breakdown will also be posted in the README. You can head over the Uniswap UI right now to verify that Alice's position has indeed decreased. Well, and that concludes our demo. Thank you for your attention.